Yay, okay. Anyway, do I need to keep going? Do we get the gist of how it's different when you have a monomial being raised to a power versus a binomial or bigger being raised to a power? It's a completely different process. All right, let's step this up a little bit. Let's say I have, actually we're not stepping it up just yet. Still keeping it as fairly simple. Let's say I have the negation of x to the 5th, y to the 4th, raised to that 4th power. Is that negative in the front being raised to the 4th power? No, that's on the outside of the parentheses. That 4th power belongs to everything inside the parentheses. Inside my parentheses, is it a monomial or bigger? It's a monomial. So can I distribute in that exponent? Absolutely. So power to a power, we multiply. So we're going to get x to the 20th, y to the 16th. What do I do with that negative in the front? Just bring it down. Right, so how does this differ from this? Right, now, does that negative get raised to the 4th power? Yeah, and what happens when you raise a negative to an even power? What happens? Claire? It becomes positive. What happens when you raise a negative to an odd power? It stays negative. So when I raise this negative to an even power, it's going to turn positive. So we'll get a positive 1 there. And then we'll get x to the 20th, y to the 16th. All right, we'll step it up a little bit now. We're going to have x raised to the 2a plus 3 power, y to the 5b power, all raised to the 3rd power. Do we agree it's still a monomial in there? Yeah, so can I distribute in that exponent? Yes, but now be very careful. So this is going to be x to the a plus 3 raised to the 3rd power, y to the 5b raised to the 3rd power. Now when I multiply these, power to a power, we multiply. I am now multiplying that 3 to a whole binomial. So what do I have to do? Distribute it, exactly. So this is going to be x raised to the 3 times the quantity of a plus 3, y, this one we could just multiply 15b. So this is x to the 3a plus 9, y to the 15b. All right, you all do this one. All right, who has something for me? David?
X power of 2a d minus c by 4bt.
How many people got that? Great, excellent. Anybody want to see me do it? Okay. So if I had x over y raised to the second power. Do you agree that's x over y times another x over y, which ends up giving us x to the second, y to the second? Yeah? We followed that process correct? All right, so what happens when a fraction is raised to an exponent? So essentially, x over y raised to the second power ended up with x squared over y squared. So what's happening when a fraction is raised to an exponent? The numerator gets that exponent, and what else? The denominator gets that exponent. So whenever you're multiplying or raising a fraction to an exponent, the numerator gets that exponent, the denominator gets that exponent. So let's say I have x over y raised to the h power. What is that? You got it, x to the h over y to the h. Let's say I have x to the second over y to the fourth raised to the third power. What's that going to be?
X to the 6th power over y to the...
You got it, x to the 6th over y to the 12th. Okay, let's do one more here. Let's have 3x over 4y to the 5th raised to the second power. Right, the numerator gets that exponent, the denominator gets that exponent. So we have 3x raised to the second power. What is 3x raised to the second power? 9x squared. What about 4y to the 5th raised to the second power? What's that going to be? Excellent, 16y to the 10th. All right, now what we're going to do is we are going to mix all the rules together. Now we're going to mix all the rules together. So when we mix all the rules together, we're going to follow order of operations. What's that special word that goes with order of operations? Aaron? PEMDAS. David? Yep. So let's say I have 3x squared times 5x to the third raised to the second power. So now in this problem, I have multiplication and I have exponents. Which one do I have to simplify first according to PEMDAS? Exponents. So I have 5x to the third raised to the second power. So when we raise that to the second power, we are going to get 25x to the sixth power. Now that we've taken care of the exponent, can I now multiply these two? Yeah, so 3x to the second times 25x to the sixth. So this is where things start becoming mush in your brain, mixing up the rules. This is where we want to be really solid on our rules. When we're multiplying, you multiply the coefficients. So 3 times 25 is 75. You keep your base, and then you add your exponents. So it's 75x to the 8th. All right, next one. X raised to the 2a y to the b times the quotient of x to the a plus 3 y to the 2b over x to the 2 minus a raised to the third power. All right, in this problem, you have an option. You can either simplify what's in the parentheses, meaning the division part. You can try to simplify that, or you can take care of the exponent first and then simplify. It doesn't matter which one you do. So you can try to simplify inside and then take care of the exponent, or do the exponent and then simplify. Like I said, it does not matter which one you do. So you tell me, what do you want to do? Do you want to distribute in that exponent first, or do you want to simplify what's inside the parentheses? Sure, let's simplify. So when we simplify, the only thing we can actually divide here are these two. Do we agree? So the rule says, I'm going off to the side of my paper, keep your base and subtract your exponent. So it's a plus 3 minus the quantity of 2 minus a. Distribute in that negative. So it's going to be x to the a plus 3 minus 2 plus a, which is going to give us x to the 2a plus 1. Where is that going? In the numerator. Very good. That is going in the numerator. So here, no more fraction left. We have the x to the 2a, y to the b. And now we have times x to the 2a plus 1, y to the 2b, all raised to the third power. Now do I distribute in that exponent? Yes. Now remember, when you distribute in that exponent to the x raised to the 2a plus 1, you have to distribute it into the 2a and to the 1. So this is going to be x to the 2a, y to the b, times x to the 6a plus 3, y to the 6b. Are we okay so far? Now what do? Now we multiply. What's the rule for multiplying? Multiply your like variables by keeping your base and doing what with your exponents? Adding them. So this is going to be an 8a plus 3, y to the 7b. Did I go too fast, or you're all keeping up? All right, we briefly spoke about negative exponents, but let's dig a little bit deeper. You may. All right, so what's the rule for a negative exponent? If I have x raised to the negative n, how do we rectify that negative exponent since we're not allowed to have negative exponents? 1 over x to the n. But let's say the negative exponent was already in the denominator. So let's say I already had 1 over x to the negative n. How do I rectify that negative exponent? Matt? You got it. You'd basically, if it's in the denominator, you're right, that would be the philosophy, but you're just going to move it up. So this would just be x to the n. So if it's negative in the denominator, move it up to the numerator. If the negative's in the numerator, move it down to the denominator. And there's one thing we didn't talk about yet. but we should all know, what is anything to the 0 power? 1. Very good. Anything to the 0 power is 1. All our rules. Okay. So let's say we start off with 3 raised to the negative 2nd power. First, we rectify the negative exponent. How do I rectify a negative exponent? I'm going to move this down to the denominator. So this is 1 over 3 to the 2nd power, which is 1 over 9. You got it. Let's say I have 5 over 2 to the negative 3rd power. Am I allowed to have a negative exponent? No. So what am I going to do? I'm going to take that 2 to the 3rd power and move it up. So it's 5 times 2 to the 3rd power. Can I simplify this further? Yeah. So this is 5 times 8, which is 40. X to the negative 2nd, y to the 3rd, x to the 5th, y to the negative 1st. Times. So you can, in this scenario, rectify the negative exponents first, or you can multiply first. For me personally, I would multiply first, because if we multiplied first, that might take care of the negatives on its own. So when we multiply, what do we do with the exponents? You add them, right? So we're going to have x to the 3rd, y to the 2nd. Is there even anything left to rectify for the negatives? No, we got that done with. All right, I'm going to do one more problem with you. Actually, I'm going to have you try this problem on your own. All right, I am not assigning homework tonight. I also have 5 problems that are really more in line, that I haven't done yet, that are really more in line of what you're up against on the test. So right now, these have just been baby steps, building to these last 5 problems. So tomorrow in class, we're going to do the 5 problems, but I also, how many textbooks do we have back there? Do we have enough? Even if people share the blue ones? We have 10, and we have 27 kids. Would Oh, great. Okay, so you do not need to bring your textbook. So tomorrow in class, what we're going to do is we're going to finish those 5 problems. Then I'm going to allow you to do the exponent homework in class tomorrow. So it's going to basically be a whole nother day of exponent practice before we move on to something else. So that is the plan for tomorrow. And I'll start off first by giving you back your test tomorrow, so I don't not do that. So somebody tell me, what did we get here real quick before that bell rings? All right. You got it. How many people got that? Okay, so nothing for you to worry about tonight. We have enough textbooks for everybody.